Divers have found something incredible in a Florida sinkhole, and it was… Stop, we need to leave a warning here. You're about to hear some pretty unusual scientific information. This knowledge will make you the smarty pants in your friend group. But there's also a risk that they'll look at you as a nerd. So perhaps it would be better for you to keep this knowledge a secret. In any case, it won't be superfluous. So, you know that scientists divide the history of our planet not only by time periods, but also by which animals lived at a certain time. For example, 2,000 years ago, Earth was inhabited by the blobfish, and scientists call this time the blobfish period. It's a joke, there's never been such a period, but you get the gist. The period between about 419.2 million and 358.9 million years ago is called the Devonian period, or the Age of Fish. Do you know why? Because the first fish began to appear on the planet. The Paleogene is the period of large mammals. The famous Jurassic period marks the appearance of giant dinosaurs, which we often see in the movies. Even now, we live in a certain period called the Quaternary period. It began about 2.6 million years ago and continues to this day. This is the time of humans and modern animals. So the next time somebody asks you what time it is, you can just answer, it's the Quaternary period. In short, the names of these periods depend more on what creatures inhabit the planet. The longest period is the Precambrian period, or Age of Early Life, the time when life on the planet started to form. Soft-bodied worms and jellyfish swam in the ocean, while microorganisms lived on land. This period occupies almost 90% of the Earth's total geological time. It started about 4.5 billion years ago and ended 540 million years ago. Oh, it's still a video about divers, don't forget. We'll get back to them soon. Considering all these periods, do you know which one is of the most poorly studied? A period about which scientists know almost nothing, especially about the animals that lived at that time. This is the Irvingtonian North American land mammal age. It lasted from about 1.6 million to 250,000 years ago. Scientists have very few fossils that belong to this time, but recently, everything has changed. In the USA, there's the Steinhatchee River, which stretches for several tens of miles in the area of Big Bend, Florida. And just 500,000 years ago, there was a sinkhole instead of the river. This is a hole in the ground that forms when water dissolves the upper rock. This rock is often limestone. Sinkholes appear in places with a lot of precipitation. Sometimes these pits can be invisible. They look like ordinary ground, but the soil in them is loose and can easily collapse. If you accidentally get into a sinkhole, people will hear your screams and help you. But in the distant past, about 500,000 years ago, when animals got there, they couldn't get out of the pit, so it became their grave. After many, many years, a river appeared here, and then several fossil collectors decided to check out this place and discovered a real paleontological treasure in it. They plunged into the river and reached the bottom. There, in the murky water, they saw horse teeth sticking out of the sediment. It'd be pretty scary to find for many of us, but for these guys, it was the jackpot. After the teeth, they found a hoof shaft and the skull of an unusual animal. At that moment, the collectors realized they had made a major discovery. Over the years, the sinkhole at this place had been filled with sedimentary rocks. Then, the river compacted all this mass, which made it possible to keep everything inside the sinkhole in good condition. Many animals got trapped in this pit 500,000 years ago, and only now have people managed to get them out. More precisely, what's left of them. Divers have found more than 500 fossils belonging to ancient animals, including unknown species. They got well-preserved bones of ancient horses, giant armadillos, sloths, and a new species of tapir. The Florida Museum examined the remains and determined that they belonged to the poorly studied Irvingtonian North American land mammal age. Most of all, scientists were struck by two finds in this collection. The first was the remains of a giant armadillo-like creature, and the second was the skull of an ancient tapir. In case you didn't know, this is a very cute pig-like mammal that has a short trunk like an elephant. Divers in Florida found the remains of a distant ancestor of this animal, which may be a new unknown species. Most of the fossils in this sinkhole belong to early Cabalene horses, a subgroup that includes modern domestic horses. The remains of horses are so well preserved that scientists have seen signs of wear on their teeth. This will allow experts to understand the diet of these ancient creatures. We often hear news about people finding the remains of ancient animals or dinosaurs in caves, ravines, or at the bottom of lakes. But imagine if they found such remains in a museum. It all started in the early 2000s, north of the Florida border in southwest Georgia. There was a mine where workers mined clay. One day, they found the remains of some ancient animals and gave them to the Florida Museum of Natural History. There, these remains lay in storage, waiting in the wings. And then one day, some guy started sorting them out and noticed a mysterious vertebra of an unknown animal. This little grab caught the guy's attention, so he returned to it over and over again. He studied it, trying to figure out what species the bone belonged to. One day, he realized the bone belonged to an unknown extinct lizard species that looked like a tegu. You've probably seen these predatory creatures that looked like monitor lizards. So, the age of the bone was about 15 to 17 million years old. Let's wrap up our video with something weird. You see this piece of amber-colored stone with stripes? Or is it not the stone? It looks like an ancient seashell. So right now, you're looking at the oldest fossil in history. It's a stromatolite, and its age is, you won't believe it. Make a guess. 100 million years? 500 million years? 1 billion? No. This fossil is about 3.4 billion years old. It represents one of the earliest forms of life on Earth. No, not the stone itself. Stromatolite is just a playground. The early form of life here is these thin strips. They're called cyanobacteria, tiny single-celled creatures. Okay, what about the remains of something bigger? Some ancient animals, for example? Meet the trilobites. They lived here during the Cambrian period, which began about 500 million years ago. This is the time when many invertebrates and fish began to appear. Their exoskeletons helped the trilobites stay remarkably well preserved, considering their age. They were arthropods that looked like something between a spider, a scorpion, and a mutant from another galaxy. These animals lived for a very long time, and people find their remains almost all over the world. They appeared at the very beginning of the Cambrian period, survived it, and became extinct at the end of the Permian period. During the Permian mass extinction, when about 90% of all living beings were wiped off the face of the Earth. These creatures swam in open water, burrowed into the seafloor, or crawled along it. They lived like predators and scavengers. The front of the animal was protected by a strong head shield. It had crescent-shaped eyes and a calcified plate on its lower body. This plate covered its esophagus and mouth. It had several pairs of legs growing from its body. The trilobite could also curl up into a ball, like a woodlouse. Giant vase-like sponges, otherworldly jellyfish, segmented worms covered with bristles, and large octopuses are the newest Antarctica discovery. Scientists found them after a giant iceberg had broken away, and it turned out to be a treasury of ancient life under ice. In January 2025, a huge iceberg the size of Chicago, called A84, broke off from Antarctica's George VI ice shelf, which is a large ice shelf about 280 miles long 12 to 43 miles wide, and around 820 feet thick. In the summer, which lasts from November to late February, the ice shelf melts at the surface, and meltwater ribbon lakes form. They're elongated and ribbon-like. That's how they got their name. Anyway, when the iceberg floated away, it left part of the ocean floor wide open, and it was a spot no one had ever seen before. Scientists on the research ship Falkor 2 were nearby in the Bellingshausen Sea. As soon as they heard about the iceberg, they immediately changed their plans. They understood that it was a super rare chance to check out something unknown and amazing, like lifting a rock in the forest to see what's hiding underneath. The researchers used an underwater robot named Sebastian and explored the deep sea for 8 days. They went as deep as over 4,200 feet. Down there, they found a hidden ecosystem. There were big corals and sponges literally packed with sea animals. A whole world under the ice. The researchers thought they'd find some life down there, but they didn't expect to see so much. And this underwater ancient life wasn't just surviving, it had been thriving in that harsh, icy place for a really long time. Anemones that looked like fluffy little trees, sea spiders, ice fish, octopuses. The research was live streamed to scientists from all over the world, and those live streams are actually in open access. The coolest thing was that some discovered creatures seemed to be new species. Yes, there are probably new species in Antarctica in 2025, and some might only live in this region. That's because Antarctica isn't just really far away. It's been cut off from the rest of the world for millions of years. The Antarctic circumpolar current surrounds it, like a big water moat surrounding a castle. But even if it turns out that those species are not new, the scientists have still found snails, worms with bristles, crustaceans, like tiny crabs and shrimp, and a species of the phantom jellyfish. Those are super rare and look otherworldly. Their official name is too complicated, so let's just call them the giant phantom jelly. This jellyfish is huge. Its bell, the round umbrella part on top, can be more than 3 feet wide. It has 4 long arms that trail behind it. Each one as long as 33 feet, about as long as a school bus. Scientists first caught one way back in 1899, but it took them 60 years to realize it was a totally new kind of jellyfish. The phantom jellyfish has a see-through purplish body that looks kind of ghostly. Instead of normal jellyfish tentacles, it has these ribbon-like arms that help it catch food and pull it into its mouth right in the middle. Even though jellyfish don't have brains like we do, researchers watching the giant phantom jelly noticed something surprising. The otherworldly creature seemed to move its arms very carefully and with control, especially when swimming through tight spaces on the seafloor. It looked like it was being very cautious and deliberate. Ugh, creepy. Another sentient being? Jellyfish have a simple nerve net instead of a brain, which helps them sense the world around them. But the way this phantom jelly moved made scientists think it might be smarter or more coordinated than other jellyfish. Studying it can help scientists learn how animals without brains still manage to explore and survive in tricky places underwater. Another cool find was little worms called bristleworms. Scientists call them polychaetes. But let's stick with bristleworms because it kinda sounds fun. Lots of different kinds of them live in super cold, deep parts of the ocean. Bristleworms have bodies made of many segments, and they have tiny little bristles all along their sides. These bristles help them move around, feel what's near them, and even protect themselves from danger. One cool example is the Antarctic scaleworm. It's a type of bristleworm that lives in really cold, deep waters and has shiny, golden bristles that make it look pretty fancy. During Antarctic deep-sea exploration, the team also found giant sponges shaped like vases. Usually, sponges grow very slowly. So to get that huge, they must have been growing there for a really long time, maybe even hundreds of years. Their size shows that the deep-sea animals living around them didn't just move in recently. Those sea creatures have been there for decades and managed to form thriving communities under the ice. So, it really was ancient life hiding under all that ice. And that surprised scientists a lot. In older studies, people used to drop cameras through holes in the ice or visit iceberg areas long after the ice had broken off to explore hidden ecosystems. Back then, they mostly saw bare, empty seafloor with just a few living things. But this time, the team arrived just weeks after the giant iceberg broke away, and they got to see what was hiding right underneath it. The first 9 miles behind the ice shelf can hide rich and busy ecosystems. The area is dark, cold, and hidden for ages, and still, all kinds of creatures live there. This shows that life can survive in places that seem too harsh or frozen for anything to live. On the other hand, finding all this life down there isn't super surprising. Lots of animals live in dark, cold places underwater, so it makes sense that they'd be under the ice shelf too. The ice kind of hides them and keeps them safe from anything going on above. But what's weird is how many different kinds of creatures live there, even though it used to be a really closed-off space. It actually looks a lot like the seabed in parts of Antarctica that don't have ice on top. How can that be? Usually, tiny plants called phytoplankton grow near the surface where sunlight hits. Little shrimp-like animals called krill eat those plants at night. When krill get full, they sink down and bring food and nutrients to the ocean floor. Even their waste helps feed the deep-sea creatures. But if there's a huge ice cap above, sunlight can't get through, so no plants can grow there and no krill bring food down that way. Scientists thought this would mean less food and fewer animals down there, but they found a lot of life anyway. Turns out, food and nutrients probably sneak in under the ice, carried by underwater currents, kind of like rivers flowing under the ocean. Scientists found some animals that lived a long time, so it looks like those currents, which mostly come from melting glacier water, bring enough food to keep the ecosystem healthy and full of life. No one really knows what's going to happen to all that deep-sea life now that the iceberg has floated away. Those creatures have lived under the thick ice for who knows how long, in super stable, pitch-black conditions. Obviously, they're not exactly fans of change, so losing that icy roof might totally mess with their whole setup. One of the scientists mentioned that the ice shelf the iceberg came from has been creeping backward, like 25 miles over the last 50 years. That's a part of a bigger pattern. Antarctica's ice is melting faster and faster, which pushes sea levels up around the world. That's why this Antarctica discovery matters. The team's trying to figure out not just what's happening now, but how this hidden ecosystem fits into the bigger picture. If we can understand how this place is changing over decades or even centuries, maybe we can predict what's coming next. And it's pretty amazing that breaking ice can tell us so much, right?
A hole about the size of Switzerland or South Carolina keeps popping up in the Antarctic ice. This opening is growing steadily, and it took scientists half a century to figure out why. They found the answer with the help of seals. The scientists first spotted this gap, called Maud Rise Polynia, in the Weddell Sea in 1974. They were about to close the case as the hole disappeared, but it popped out again in the following 2 years, and then only in 2016. The giant hole is near Maud Rise, an underwater mountain. This type of hole is a polynia, a rare patch of open water surrounded by thick sea ice. In Antarctica, when winter hits, the ocean surface freezes, and sea ice spreads out to cover an area about twice as big as the continental United States. Along the coast, openings in the sea ice pop up every year. This happens when powerful coastal winds blow off the continent and push the ice away. But it's a whole lot rarer for these openings to form way out over the open ocean, hundreds of miles from land, where the water is thousands of feet deep. Researchers from several universities teamed up to study the Maud Rise Polynia using computer models and satellite images. They even recruited some Antarctic seals to help out. These seals wore tiny helmets on their furry round heads with tracker sensors attached to them. Thanks to these sciencey seals, the team could collect water data from the source. After the research, the scientists discovered that the hole resulted from a complex mix of factors. The wind, ocean currents, and the special shape of the ocean floor all work together, moving heat and salt up to the surface. In science talk, this swirling movement is called an Ekman transport. Ekman transport is what happens when wind messes with the surface of the ocean. When the wind blows across the water, it creates friction that grabs onto the top layer and pulls it along. Thanks to the Coriolis effect, which comes from Earth's spinning, the moving water gets pushed at a 90-degree angle from the wind's direction. So, instead of the water going exactly where the wind is pushing it, it drifts off at an angle. Which way it turns depends on which half of the planet you're on. In the northern hemisphere, the water shifts clockwise from the wind direction, and in the southern hemisphere, it shifts counterclockwise. Now, Ekman transport turned out to be the missing piece of the puzzle in the case of the Maud Rise hole. It helped balance the salt levels and keep mixing salt and heat up to the ocean surface. But as the sea ice melts, the surface water becomes less salty, which should stop the mixing. So the scientists realized something else had to be happening to keep the Paulownia open. There had to be another source of salt. Salt lowers the freezing point of water. To find out where this extra salt was coming from, the team dug back into their data and ran more computer models on the ocean. They found that swirling currents formed as the Weddell current flows around Maud Rise. These currents carry salt up to the top of the underwater mountain. From there, Ekman transport kicks in. As the top layer of water moves away with the wind, water from deeper down rises to take its place. At Maud Rise, this upwelling water brings along the extra salty water built up around the seamount, and that's what helps keep the Paulownia from freezing over. Scientists follow any changes in Antarctica as they influence the rest of the world. Researchers at Stanford University used machine learning for the first time to study detailed satellite data showing how ice moves in the polar region. They combined huge amounts of real-world data with physics rules to understand the Antarctic ice sheet better. It's the biggest ice mass on Earth, almost twice as large as Australia. It acts like a giant sponge for the planet, storing fresh water as ice and stabilizing sea levels. Scientists used to rely on models based on lab experiments, but real Antarctic ice is way more complex, with cracks, air pockets, and different types of ice that behave unpredictably. Instead of trying to model every little detail, the team trained a machine learning model using data from 2007 to 2018. It looked at 5 major ice shelves and created new models showing the ice's resistance to flow. They found that near the land, the ice is compressed and behaves as in lab predictions. But farther out, the ice is stretched toward the ocean and acts differently depending on direction. Less than 5% of the ice shelf is compressed. The other 95% behaves in a way old models didn't fully explain. This research could seriously improve our predictions of how Antarctica might change in the future. Another recent piece of big scientific news from Antarctica changes the history of birds as we know it. For a long time, it was simple. Dinosaurs ruled the Earth until an asteroid hit 66 million years ago and wiped them all out, except for some avian dinosaurs, which eventually became birds like eagles and chickens. Now, scientists have found a headless fossil of a VYI on Vega Island in Antarctica. The fossil was 68 million years old, at least 2 million years older than the asteroid strike. Without a skull, it was unclear what modern birds VYI might be related to, and guesses included waterfowl and shorebirds. Nearly 20 years later, another expedition found a bird's skull in Antarctica. After careful study, scientists matched it to VYI and concluded it was an ancestor of modern water birds like loons and grebes. If it's all true, VYI is now the oldest known modern bird in fossil records. The skull had a long, pointed beak, a brain unlike any other Mesozoic bird, and signs of strong jaw muscles like mine, which were perfect for diving underwater and catching fish. The body fossil also had adaptations for underwater swimming, similar to modern diving birds. During the late Cretaceous period, Antarctica was a temperate rainforest far from the Yucatan, so it could have become a safe haven during the asteroid disaster. So, early modern birds might have survived there. When a giant iceberg, about the size of Chicago, broke off from Antarctica's massive ice shelf, scientists nearby did something no one had ever done before. They sailed straight over to check out the newly exposed seafloor. Studying the undersides of ice shelves is incredibly hard, but thanks to the iceberg A84, a 209 square mile patch of seafloor suddenly opened wide for exploration. The scientists deployed all their high-tech gear, including a remotely operated submersible and autonomous robots, to collect data about the seafloor and the properties of the water above it. Life exists almost everywhere in the ocean, from the bright, shallow waters to the pitch-black, volcanic deep sea. But the research team was really surprised to find such a diversity of life down there. They found a forest of sponges, giant sea spiders, ice fish, octopuses, huge corals, anemones, and even glowing deep-sea jellyfish. Normally, deep-sea creatures get their nutrients from organic matter falling from the ocean surface. But under a 500-foot thick sheet of ice that had been there for who knows how long, that wasn't possible. That meant the creatures had to be getting their nutrients in some completely different way. To figure out how long this hidden ecosystem had been around, the scientists studied the sea sponges. Sponges grow extremely slowly, only about an inch per year, but the ones they found were huge, so they must have been growing there for decades or even centuries. The team is hoping that the mountain of ocean and environmental data they collected during the expedition will help them understand how these ecosystems managed to thrive in those conditions and maybe reveal some completely new species that no one has ever seen before.
You're down in one of those polar seas where the Brinicle, eerily called the Finger of Death, is born. It's a strange, almost otherworldly place, the deep ocean, where light barely reaches. Everything down there seems to have adapted to survive in darkness and intense cold. But even those truly hardy creatures aren't ready for what a Brinicle can do. When that briny, super-cooled water starts dripping down, a ghost story begins. The formation of these brinicles is a fascinating process, like an underwater science experiment happening in real time. We know that when seawater freezes, it doesn't freeze like fresh water. Because of all the salt in it, it has to push out impurities to form the pure ice that floats at the top. This means the salty water, or brine, ends up trapped in channels and pockets within the ice. When it sees the light of day for the first time, a brinicle resembles a pipe of ice reaching down from the underside of a layer of sea ice. At first, a brinicle is very fragile and its walls are thin. But the continuous flow of colder brine supports the growth of the brinicle. It also prevents it from melting. Otherwise, this process would be inevitable, caused by the brinicle's contact with less cold surrounding water. As the ice accumulates and the walls become thicker, the brinicle becomes more stable. Over time, the brine trapped inside gets squeezed out through tiny cracks, dripping down in this cold, heavy plume. Once that cold brine starts flowing downward, it begins freezing the seawater around it into a sheath of ice. That's why, instead of melting as it hits the water below, it forms this icy casing that protects it, helping it grow longer and stronger. The brinicle keeps moving forward inch by inch, and this crazy downward spiral is almost unstoppable. And when it touches down on the seafloor, that's when the trouble begins for anything living nearby. Imagine being one of those creatures on the seafloor, maybe a sea star or an unsuspecting urchin just trying to make it through the day. And all of a sudden, you see this icy tentacle nearing you. It isn't just some cold water coming down. It's basically a net of ice moving down and spreading out. There's no escape, No way to predict its coming, and no chance for survival. It's a slow-motion natural disaster in action. When a brinacle reaches the seafloor, it continues to accumulate ice while the surrounding water freezes over. The brine keeps traveling across the seafloor in a downslope direction. Once it reaches the lowest possible point, it stops and pools. But don't let the danger distract you from how beautiful brinicles are. Well, in their own creepy way. They look like something you'd see in a dream. Elegant, twisting ice tubes reaching down, perfectly symmetrical, and totally random. Filming a brinacle is no easy task because they're delicate when they first form. Just the motion from a nearby current or a sudden change in temperature can snap them off, ending the show before it really starts. So, scientists who managed to capture brinicles on film in 2011 actually got incredibly lucky. It was the first time the world got to see this icy finger descending and freezing everything it touched, and it changed our understanding of polar ecosystems. Brinicles can reach quite impressive sizes. Sometimes they can stretch for several feet. Their size depends on the conditions of the water and ice above. The slower the water movement and the colder the temperature, the bigger and stronger a brinacle can grow. But if the water's too deep or if there's too much movement in the current, the brinacle is likely to break apart. It needs just the right balance to survive long enough to touch down and freeze over the ocean floor. For creatures living on the seafloor, brinicles are like invisible booby traps. Only instead of avoiding a net, they're avoiding an expanding ice cage. Starfish and sea urchins might not have big brains, but they have a basic survival instinct to crawl away from danger. Sadly, with brinicles, they're usually caught completely off guard. One second they're minding their own business, the next, an icy sheet is closing in around them, trapping them where they are and freezing them almost instantly. It's hard not to feel sympathy for these creatures, right? You watch footage of a brinacle in action and you see a starfish just stopping. One moment it's moving slowly along the sand, and then it's frozen in place, totally helpless. It's like watching a train wreck in slow-mo. Luckily, brinicles present danger only to smaller marine life forms like sea urchins and starfish. Bigger animals like seals or whales, or humans who happen to go diving in the ocean at the frigid poles, brinicles are totally harmless. At the same time, for scientists, this tough natural phenomenon offers a fascinating insight into how life adapts, or fails to adapt for that matter, in extreme environments. And it gets even better. A brinacle might just be the perfect setup for life to begin. Researchers are now looking at these super salty ice tubes as not just fatal traps, but potentially as sources of life. This theory isn't just science fiction, it's rooted in actual research. Here's how it goes. The brine channels in sea ice are full of tiny, confined spaces. Those are exactly the kind of places where chemicals can get trapped, concentrated, and start interacting in interesting ways. It's like setting up a mini-lab where the building blocks of life can come together and create something new. Scientists think this process of salt rejection in sea ice could have actually helped the first bits of life appear. Some researchers even think that this process might be happening right now on icy moons like Europa, Ganymede, or Enceladus, where there might have been frozen seas beneath thick ice layers. Just imagine it. Brinicles forming in other worlds of our solar system, laying down the foundations for extraterrestrial life, and all thanks to the same icy process that creates these fingers of death here on Earth. One way scientists describe brinicles is by comparing them to chemical gardens. Have you ever done one of those experiments where you mix metal salts into a solution and watch them produce plant-like structures? Well, you can observe a similar chemical process when a brinacle is in action. In the cold, saline-rich brine of a brinacle, certain reactions could kick off to create amino acids or other building blocks of life. It's wild to think that something so dangerous could have also helped shape our world, or could be creating other forms of life elsewhere. In both cases, whether on Earth or another planet, These icy chemical reactions might be the first step toward the formation of simple life forms. It's a kind of alchemy, where ice and salt water mix to create something more than the sum of their parts. This is one reason why scientists are so eager to study brinicles. Each one could hold a tiny clue about how life begins, survives, or fails under extreme conditions. Something as mesmerizing and weird, but at the same time simple as brinicles, hints at bigger questions. How did life start on Earth? What are the conditions needed for life to survive in extreme environments? Could icy structures like these exist in other parts of our solar system or beyond, creating similar conditions that might one day give rise to alien life? As much as they look like a silent threat reaching out from the ice, brinicles are also reminders of how beautifully complex and interconnected our world is. They may seem like simple fingers of ice, but they hold secrets that touch on everything from ecology to chemistry to the origins of life itself. So next time you hear about the ocean, remember that deep below in the darkest, coldest waters, something incredible and a little bit terrifying is happening right at this moment. In 1985, Chilean biologist Dr. Daniel Torres was doing a census of mammals and collecting marine refuse on Cape Sheref in Antarctica. He was going to pick up a big plastic container when he noticed one white rock among the dark volcanic stones. It turned out to be a human skull, and as Dr. Torres found later, it belonged to a young woman who lived in southern Chile. She was most likely in her early 20s and starving when she passed away. Several years later, scientists also found fragments of femurs and used DNA analysis to prove they belonged to the same lady. This discovery could change history as we know it. How did a female skull end up in Antarctica, at a spot where sealers used to camp? Women usually wouldn't go on sealing trips in the early 1800s. To add to the mystery, there was nothing else found at the site. No papers, no special markings, no tools or other objects that could tell us who she was, what happened to her, or how she ended up there. It could mean that people from Chile had a camp here before anyone else set foot on the continent. Scientists made another unique discovery in Antarctica, an ancient meteorite fragment that could be proof there's life on other planets. They believe this meteorite is over 4 billion years old and it might have come straight from Mars. In 1996, NASA scientists announced that they found special chemical marks on the rock. Some ancient Martian organisms may have left them behind, but not everyone was convinced. And later studies found that the carbon-rich chemicals on the rock probably weren't biological at all. Long ago, when Mars was a much wetter place, massive space rocks collided with the planet. These collisions produced intense heat and changed the landscape. The rock found in Antarctica likely survived 2 such impacts before a third powerful strike hurled it into space. While still on Mars, this rock bathed in water that moved through tiny cracks in its surface. This water probably left behind strange carbon bubbles that scientists thought might be the fingerprints of ancient life. Researchers recover more rocks from space in Antarctica than in any other part of the world. But you don't expect to see a pyramid there, right? I could make you try to solve this mystery, but okay, this object only looks like a pyramid. In fact, it's a mountain. You can easily find it on Google Maps if you scroll all the way to the Ellsworth Mountains. It's the tallest mountain range in Antarctica, and it stretches for almost 250 miles. Explorers from the British Antarctic Expedition first found this unusually shaped mountain and nicknamed it the Pyramid. Over the past 100 years, many people have wondered if there really was a pyramid in Antarctica, and if yes, who built it? But scientists totally rained on this icy parade as they explained there is nothing unusual about a rocky peak showing above the ice. It's just a coincidence that this one and the neighboring peak are cut in a pyramid shape. Researchers at the University of Colorado found a 10,000-year-old hunting tool near Yellowstone National Park. It was buried in ice, but as it melted because the temperatures got warmer, the tool came to the surface. Researchers were keeping this find a secret for a year. They wanted to get the findings published in a scientific journal before amateur archaeologists would get there and start their own search operations on the site and disturb it. The dart, which is about 3 feet long, was made from a birch tree, and it still has some markings that prove that it belonged to an ancient hunter. In the good old days when it was actively used, the dart had a sharp tip on one end. The other end had a little dimple that connected to a hook on a special tool called an atlatl. That atlatl helped the hunter throw the dart much faster and farther than they could just by hand. Talk about ancient tech. The scientists who found the dart say that as the ice continues to melt, they keep finding more ancient tools, plants, and even animal remains in places like Alaska, Canada, and Europe. They plan to go to Glacier National Park in Montana to work with Native American tribes to find and protect any more treasures that may have been hidden in the ice for thousands of years. Paleontologists found something amazing in Antarctica: the remains of a creature that looked a lot like the Loch Ness Monster. The animal they found was a plesiosaur. This marine beauty swam in the ocean during the time of the dinosaurs. This big guy had 4 flippers, a long neck, and measured an impressive 36 feet long from its head to its tail. That's about as long as a big telephone pole. This specific type of plesiosaur is the largest one scientists have ever discovered. It was also very bulky, around 15 tons. That's about as heavy as 2 modern elephants. The fossils of this giant sea creature were first found on Seymour Island in Antarctica back in 1989. But the plesiosaur was so huge and stuck in such hard rock that it took the scientists 3 more trips to get all the fossils out. In the end, they brought 1,760 pounds of fossilized bones to the lab. The scientists noticed that some of the vertebrae bones were fused together, which means this plesiosaur was a fully grown adult. After studying the fossils, scientists decided it had lived 30,000 years before the mass extinction that wiped out dinos about 66 million years ago. In May 1845, Captain John Franklin set off from England with 133 people and 2 ships. They were trying to find a sea route called the Northwest Passage to make traveling between Europe and Asia shorter and faster. The last people who saw Franklin and his crew were sailors on 2 whaling ships in August of that same year. After that, no one knew what happened to them, and it became a big mystery that lasted almost 170 years. People sent search teams to the icy parts of northern Canada, where they found some spooky clues. There were things left behind by Franklin's crew, and they heard sad stories from Inuit people who lived there. They even found a note from 1847 on King William Island, written by one of the crew members. The note said the 2 ships had gotten stuck in the ice. Finally, in 2014, Canadian scientists announced that they had found the wreck of the Erebus at the bottom of the Wilmot and Crampton Bay. 2 years later, they found the second ship, about 45 miles away. Both ships were still in great shape, even after being underwater for so long. Underwater archaeologists studied the cabins on the ships and brought back hundreds of objects. Thanks to these artifacts, they can paint a better picture of what really happened during the last days of Franklin's dangerous journey. A mountain hiker found an unusual sandal in an area known as the Horse Ice Patch in Norway in the summer of 2019. The hiker sent GPS coordinates and photos of the find to researchers who study archaeology preserved within glaciers and ice patches. The archaeologists checked the weather forecast and figured out that they only had 1 day to retrieve the show before the snow covered it with a thick blanket. Then it would take years for it to melt, so they had to act fast and rush to the location to secure the sandal. This vintage shoe turned out to be around 1,700 years old after radiocarbon dating. They also found other artifacts in addition to the Iron Age footwear, such as frozen horse manure from the Viking Age and textiles. All these findings could mean that there used to be a travel route in the mountains that connected inland Norway to the coast a long time ago. These dark patches on Greenland's ice sheet aren't just any old stains. Every summer, the ice, which is usually bright white, turns murky gray in certain areas. This so-called dark zone was a huge mystery for a long time, until some studies discovered that this weird transformation was connected to the odd appearance of red, green, and brown-colored algae. The scariest part is that this algae bloom keeps growing. The dark zone is getting darker, and terrifying microbes might start appearing. Now, the rest of the world should be concerned. The Greenland ice sheet is like a massive ice blanket that covers around 80% of the island. It's so thick that it holds about 8% of the world's freshwater ice. For most of the year, the ice looks like a giant untouched white sheet stretching over the land. But when summer rolls around and temperatures start to rise, things begin to change. The ice melts, revealing rocky areas along the coast. And as you move further inland, that once smooth white ice becomes darker. This is the dark zone, and it covers an area of around 248 miles in length and 62 miles at its widest point. This weird phenomenon happens basically for two reasons. The first one is black carbon. Just like dust that builds up on your bookshelf, the ice in Greenland has the same issue. The wind carries a mix of dust and soot to this icy area. But unlike your bookshelf, you can't just wipe it off with a cloth. In Greenland's case, this dirty mix settles on the ice and sticks around for thousands of years. So, the dark zone is basically covered in a fine layer of dust that's built up over time. Back in 2014, researchers analyzed this dirty mix and found that the darker ice areas were filled with black carbon. This black carbon didn't just appear out of thin air. Well, actually, it sorta did. Scientists believe it mostly comes from smoke produced by wildfires in northern Canada and Alaska somewhere in the past. As you might guess, black carbon is black, which is why it makes the ice look darker. Now, the second big reason for the Greenland ice sheet's summer makeover has to do with those algae we mentioned earlier. We're mostly talking about two types of it, the Ansellonema alaskana and the Ansellonema nordenskjoldii. Both of them love cold water regions. During winter, they stay in a dormant state deep within the ice. But when spring comes, they start to slowly migrate to the surface. By the time summer hits, they're ready to bloom and soak up nearly 24 hours of sunlight each day for photosynthesis and growth. Normally, these algae are green, but when exposed to sunlight, they turn brown as a natural way to protect themselves from harmful ultraviolet rays. And this color change is also what makes the ice in Greenland look darker. So far, this has been normal behavior. What's really alarming is that these algae blooms are getting bigger and bigger every year. This happens because they thrive on phosphorus, a nutrient that's plentiful out there and comes from a mineral called hydroxylapatite. This mineral is found in a type of rock that breaks down into tiny dust particles, which are then blown across the ice by the wind. As the climate gets warmer, the rocks dry out more, and stronger winds carry more dust. More dust means more phosphorus, leading to more algae growth. See? It is a cycle, and it keeps getting worse every year. Studying this is crucial to understanding why the dark zone keeps getting bigger. From the year 2000 to 2012, its size increased by 12%. But you might be wondering, why should we care? After all, it's just ice getting darker, right? Well, not exactly. Think about how you can't stand wearing black clothes on a hot, sunny day. They soak up the heat and make you feel even hotter. That's because darker surfaces absorb more sunlight. The same thing happens to ice. Together, dust, black carbon, and algae blooms are responsible for about 70% of the variability in albedo on the Greenland ice sheet. Albedo is just a fancy word for how reflective a surface is. If you take two surfaces, one white and shiny and the other dark and rough, the white one will reflect a lot of light and heat, giving it a high albedo. The dark one, on the other hand, will absorb more light and heat, so it has a low albedo. During the summer, the Greenland ice sheet experiences a reduction in albedo. This means the ice absorbs more sunlight, and when ice absorbs more sunlight, it melts faster than it should. This is why understanding what's happening in the dark zone is so important. It helps predict how quickly the Greenland ice sheet is melting and how it can affect the rest of the world. Greenland's ice sheet is the second largest in the world, covering an area about the size of all the land in the United States east of the Mississippi River. And its huge mass of ice averages a thickness of 1.4 miles. Unfortunately, the ice loss has skyrocketed. Back in the 1990s, Greenland was losing about 25 billion tons of ice per year. Now, it's losing around 234 billion tons per year. That's nearly 10 times more ice melting away each year. According to NASA, if all of Greenland's ice sheet were to melt, it would increase global sea levels by about 24 feet. That could be catastrophic for coastal countries and cities around the world. The Netherlands could be submerged, the Bahamas could be almost completely wiped out, and many of the Philippines Islands would be at risk of disappearing. All of this may seem like a distant reality, and it is true that most scientists believe it would take several hundred or even thousands of years for the ice sheet to melt completely. But it is important to know that Greenland didn't always have this thick layer of ice. Very recently, researchers took a close look at some sediment from the bottom of a 2-mile deep ice core extracted from the center of Greenland. They found that the soil had traces of willowwood, insect parts, fungi, and even poppy seeds. So these fossils are the first direct evidence that Greenland's ice sheet melted away in the recent geological past, around 400,000 years ago. At that time, Greenland was home to a green tundra landscape with insects and plants. This discovery is both fascinating and scary because it shows that the ice sheet collapsed before and might be more fragile than scientists originally thought. There is another concern too. A recent research collected meltwater from different spots on the Greenland ice sheet and found that the water samples were packed with hundreds and thousands of microbes. The concern is that they could be released into the ocean in the future. And some studies already suggest that areas near where a lot of glacial meltwater flows have a higher risk of viruses jumping to new hosts, like from animals to humans. Even though experts believe the chance of a doomsday virus coming from the glaciers is very small, it's still not zero. The truth is, we don't know much about the thousands of microbial species living on the surface of the ice, and there is simply not enough data to fully understand how dangerous these organisms might be. All of this might sound concerning, but we shouldn't panic just yet. There's still a lot we don't understand about what is darkening the Greenland ice sheet. We still need more detailed measurements of the relative abundance of dust, algae, and black carbon, as well as a better understanding of how these potentially dangerous microbes could affect our lives. The more we learn, the better we can predict what's going to happen and how we can prepare for it.
Ooh, mysterious mountain ranges hidden under thousands of tons of ice. Bizarre, transparent creatures with see-through skin, singing snow plains. Antarctica has its own terrifying secrets. And now, a mysterious ice hole the size of Switzerland that keeps popping open. And scientists have finally figured out why. This hole, called the Maud Rise Polynya, was first spotted in 1974 and 1976 in the Weddell Sea. Since then, it's been kind of playing hard to get. Sometimes it appears, sometimes it disappears for years. And when it does show up, it mysteriously changes size. For decades, researchers were trying to figure out what makes it form. Then, in 2016 and 2017, The Polynya went absolutely massive, more than 30,000 square miles. The hole stuck around for several weeks during winters. It was the first time since the 1970s that the Weddell Sea had such a huge, long-lasting Polynya. Here's the deal with Antarctic sea ice. In summer, the ice is at its smallest, around 1 million square miles. Yeah, that's considered small. By winter, it spreads to a whopping 7 million square miles, covering about 4% of Earth's surface in weird white tiles. Most of this ice grows during the weeks-long polar night on the floating ice shelves around the continent. These holes in the ice, called polynyas, usually form when strong winds from inland push the ice tiles apart. That same cold wind also freezes more seawater inside the hole, adding extra chunks to the ice sheet. But the Maud Rise Polynya isn't near the coast, where those winds normally help make holes. Out in the open ocean, holes like this are rare. Add in the fact that ice across the Southern Ocean has been shrinking. No wonder scientists are left bewildered. What exact conditions are creating this stubborn giant ice hole? To crack the mystery, the scientists dove into a mountain of data: satellites, floating sensors, even info from tagged marine animals. Plus, they had years of past observations from other researchers. And they found something unusual. In 2016 and 2017, the Weddell Sea's circular ocean current, called the Weddell Gyre, was stronger than usual. That extra punch made it easier for salty, warmer water from deep below to reach the surface. The Maud Rise Polynya sits above an underwater mountain called Maud Rise. During those big Polynya years, the stronger current caused salt to gather around this submerged peak. On the surface, the wind whipped over the ice, creating a corkscrew effect. It literally pulled that salty water up from below. The extra salt lowered the freezing point of the surface water, allowing the Maud Rise Polynya to form and stick around. Polynyas are really important for the planet. The dense salty water formed in these holes can travel huge distances, spreading across the global ocean and affecting climates everywhere. But these magnificent holes aren't the only cool and mysterious phenomena Antarctica is famous for. How about underground lakes? Or shall I say under-ice lakes? Because there are entire lakes hidden under Antarctica's thick ice. Scientists first found them back in 1970 using radar, and now they think there are around 400 lakes tucked under around 2 miles of ice in the explored areas. These lakes likely formed after Antarctica broke off from Gondwanaland, the ancient supercontinent. Surprisingly, the water in the lakes doesn't freeze because the ice above presses down too hard. Hey, it's physics, bro! The biggest of them all is Lake Vostok, discovered in the 1990s. It sits a bit more than 2 miles below the ice. Scientists have drilled down to take samples, and the water they pulled up was about 26 degrees Fahrenheit, even though the lake had been trapped under ice for over 20 million years. There's also Lake Williams. In 2014, scientists made a lit discovery there. They found a thriving colony of microorganisms nearly a mile under the ice. Those tiny creatures never saw sunlight or fresh air. Instead, they used methane and ammonium as energy to grow. Another marvel hides in plain sight in the McMurdo Dry Valley. It's a waterfall that looks like something straight out of a horror movie. Bright crimson water, like blood gushing from a wound in the ice, pours down 5 stories from Taylor Glacier into Lake Bonny. Ooh, spooky. But there's actually a scientific reason behind it. The water that feeds Blood Falls used to be part of a salty lake. Now, it's completely cut off from the atmosphere because glaciers formed on top of it. Trapped more than 1,300 feet underground, the water has become super salty, 3 times saltier than seawater, and it can't freeze. This underground water is also packed with iron and completely lacks oxygen and sunlight. When it slowly seeps through a crack in the glacier and hits the open air, the iron oxidizes, basically rusts, and turns the water that eerie dark red. With such creepy landscapes, Antarctica might look like a frozen wasteland, freezing cold, almost no rain, and winds that could knock you off your feet. The coldest Earth's temperatures ever was recorded there, minus 128.6 degrees Fahrenheit. And still, Antarctica is actually home to some seriously bizarre wildlife. For the longest time, scientists thought nothing could survive under all that ice. Turns out, they were very wrong. There are all sorts of creatures that have adapted to the brutal environment. Tiny microbes, crustaceans, colossal squid, and spiders so big their legs could cover a dinner plate. Giant worms with shiny golden bristles and huge sharp-toothed jaws also lurk under the ice. And then there's the ice fish, a completely see-through fish with huge eyes and organs you can literally see through its skin. These fish have built-in antifreeze proteins to survive the freezing waters, and they can't live anywhere warmer. Even stranger, they don't have hemoglobin, the protein that makes our blood red. In other words, they survive without the stuff that literally keeps most animals alive. But Antarctica wasn't always the frozen desert we know today. Millions of years ago, before the Ice Age, it was actually warm, lush, and full of life, maybe even home to ancient civilizations. Hard to imagine, huh? Scientists figured this out after finding fossilized wood, tropical tree remains, and leaf impressions, all pointing to the existence of rainforests. On top of that, they've uncovered fossils of marine animals, birds, and dinosaurs from the Cretaceous period. Even tiny creatures left their mark. Fossilized beetle wings from 14 to 20 million years ago, single-cell fossils, and, astonishingly, 50-million-year-old sperm cells preserved in the egg case of an extinct worm. So now, it probably won't shock you when I tell you that beneath Antarctica's thick ice sheets, there's a massive hidden mountain range. The Gamburtsi Mountains stretch for 745 miles and rise to almost 10,000 feet, about the third the height of Mount Everest. And all this is buried under between 6,500 to 13,100 feet of ice. The mountains were discovered in 1958. Scientists noted a thin patch of ice and some weird gravity readings while crossing the continent. Even though no one has ever seen those mountains directly, researchers use radar to map their shape and gravitational and magnetic readings to study them all the way to their base. Perhaps the craziest part is that the Gamburtsis are around 1 billion years old. So, in theory, they should have eroded away long ago. How they're still standing is a mystery. Most scientists think a frozen mantle beneath the ice might be protecting them from erosion, keeping this ancient range intact. And finally, Antarctica has its own soundtrack. The Ross Ice Shelf, the continent's largest ice shelf, is several hundred feet thick and spreads over 193,000 square miles, roughly the size of France. And scientists have recently discovered that this massive ice slab actually sings. The eerie melody comes from wind blowing over snow dunes, which creates vibrations in the ice and a nearly continuous seismic hum. You can't hear it with your ears, but seismic sensors pick up the mournful tune. In fact, it was discovered by accident. Scientists just installed special sensors to monitor other ice behaviors. Now, even cooler, the song changes depending on what's happening on the ice. Melting, storms, and shifting snow all tweak the vibrations. Researchers are now using this haunting melody as a kind of early warning system. They listen to it in real time to track the ice shelf stability and potential collapse. Nearly 12,900 years ago, hey, I wasn't around then, but something happened that pushed the northern hemisphere back toward the Ice Age. For years, scientists thought the cause was a huge asteroid, but new research points to something that was here on Earth all along. A volcano hidden beneath ice or underwater that, instead of melting the ice, did the opposite and made Greenland even colder. Scientists call this abrupt deep freeze the Younger Dryas. Despite how it feels with those unbearable summer heat waves around the world, Earth is still technically in an ice age. Earth's orbit and axis go through all kinds of tilting and wobbling, which is why we swing between colder glacial and warmer interglacial periods. Right now, we're in an interglacial period, named the Holocene. But before civilizations could really grow crops and enjoy summer, they had to endure this unexpected freeze that lasted for about 1,300 years. Evidence from Greenland suggests this change happened within just a few decades. Temperatures dropped by more than 27 degrees Fahrenheit, winds got stronger, and the entire North Atlantic started acting like someone turned the freezer up a few notches. In Europe's sediments, the plant record flipped back to cold climate tundra. That shift even brought back a tough little Arctic flower, Dryas, in the middle of Europe, and that's what this sudden, teeth-chattering cold spell was named after. But why the unexpected brrr? The clue comes from deep inside the Greenland ice sheet. All that endless ice is like the Earth's hard drive, with all the events sorted in order. When it snows in Greenland, the snow doesn't really melt away. Instead, more snow just keeps piling up on top of it each year. Over time, all that weight squashes the layers beneath, turning them into ice. This process captures tiny air bubbles that hold bits of the atmosphere. Basically, the frost keeps a snapshot of whatever was happening in the sky at that time. For example, if there was a big forest fire in Canada 5,000 years ago, the smoke and soot would drift over to Greenland and settle on the snow. If a big asteroid impact really happened around then, you'd expect its chemical traces to show up in the ice layers from that time. Now, to access this data, scientists use massive hollow drills. They drill deep into the ice and pull up long cylinders called ice cores. And because Greenland's ice is nearly 2 miles thick, those cores can preserve a ridiculously long climate record, allowing scientists to examine ice that's over 100,000 years old. By examining ice cores from that period, researchers found a sudden spike in platinum. This element is super rare near Earth's surface, but it's much more common in meteorites and asteroids. That's why theories were pointing to something huge from space. But how could an asteroid cause climate change? Well, basically, it works like this. Let's say a giant rock slams into an ice sheet. The impact blasts dust, ash, and all kinds of particles high into the sky, way above the clouds. Big booms can cause massive fires, adding even more smoke. Now the planet is wrapped in a dusty, smoky layer that blocks part of the sun's energy. The thing with ice is, when it doesn't melt, it spreads and reflects sunlight back into space, which makes things colder again. That loop is called the ice albedo feedback. Sounds like a cool theory for the younger Dryas. And just to make it even more tempting, Greenland also seems like it might be hiding the actual crater. Radar surveys beneath the Hiawatha Glacier revealed a round structure about 19 miles wide. Scientists were wondering if this was the one that caused the younger Dryas, but dating showed it was about 58 million years too old to be the culprit. Also, a platinum spike doesn't automatically mean a meteor. Platinum from space usually comes with a supporting buddy metal called iridium. If you find one, you should find the other. But when scientists analyzed the Greenland ice, iridium was missing. So the chemistry didn't really point to a meteor. It looked more like volcanic magma from the North Atlantic. Then there's the shape of the platinum signal. It drains on for multiple years, not one sharp boom layer. That's more like something steadily feeding the atmosphere, not one big explosive impact. So, if platinum isn't pointing to a fresh impact, the next question is simple. What on Earth can put platinum into the sky and also cool the planet? The answer is a volcano. The kind they're talking about could have been in the North Atlantic region, possibly in Iceland, and it may not have even been fully on land. It could have erupted under thick ice, or underwater. Here's the difference. When a volcano blows its top in the open air, we get ash clouds and oozing lava rivers. But under the ice, magma hits meltwater, flashes it into steam, and can explode into fine ash and gas. Underwater, powerful eruptions can also fragment magma and push material upward. In both cases, the real trouble isn't the molten rock, it's the gas. Hey, I can relate. Now, big eruptions like these spit out massive amounts of sulfur dioxide. If that gas gets high enough, like miles above the clouds, it spreads out and mixes with water vapor to create sulfate aerosols. These are basically microscopic droplets of sulfuric acid. Individually, they're invisible, but get billions of them floating together and they act like a planetary shade. From space, Earth actually looks shinier because those droplets are reflecting sunlight. But down here on the ground, it's like looking at the sun through a thin, silvery veil. You don't need total darkness to freeze the world, you just need to dim the sun a little. Summers stop being truly warm, and snow survives into July. That leftover snow compacts into ice, which reflects even more sunlight. It's the same kind of feedback loop as the one triggered by an asteroid, except in that case, the sun is blocked by dust, while here, it's reflected back into space. Something similar happened quite recently. In 1991, Mount Pinatubo in the Philippines unloaded about 20 million tons of sulfur dioxide into the stratosphere. It wrapped Earth in a thin veil, and global temperatures dipped by about 1 degree Fahrenheit for about 2 years. Just imagine the scale of the eruption if Greenland's temperatures had dropped by more than 27 degrees Fahrenheit and stayed that cold for 1,200 years. But here's an interesting question. Could it be neither? Not a climate-changing asteroid, nor a hidden volcano. There's a third suspect that's much quieter but just as dangerous: fresh water. One leading theory is that the world warmed up and a massive glacial lake in North America, often linked to Lake Agassiz, suddenly drained or rerouted, dumping an absurd amount, like quadrillions of gallons, of fresh water into the North Atlantic system. That fresh water diluted the surface ocean in regions where dense, salty water normally sinks and helps drive large-scale Atlantic circulation. When that sinking weakens, the overall circulation slows down and less ocean heat reaches the North Atlantic. With that system disrupted, the Northern Hemisphere could cool extremely fast on a climate timescale, within years to decades rather than centuries. In that version, the platinum spike could be a coincidence, a volcanic burp during the freeze, not the trigger. And in the end, if the volcano was the cause of the endless winter, could this happen again in our time? Absolutely. The North Atlantic region is still geologically active. Iceland erupts regularly, and the volcanic systems along the Mid-Atlantic Ridge are very much alive. But it wouldn't be a jump scare out of nowhere. Even volcanoes buried under the ice usually give warnings, like earthquakes. If heat builds down there, it can melt large volumes of ice from below before anyone sees ash in the sky. On the other hand, it wouldn't need to be a planet-destroying eruption. A moderate blast that injects sulfur high into the stratosphere could dim sunlight for a couple of years, just like Pinatubo did. That does not mean a new ice age will start the day after. Today's climate background is very different from 12,800 years ago. But the mechanism is real. The atmosphere can still be nudged, and sometimes all it takes is a hidden eruption. Summers disappear. Rivers turn into ice. Crops fail. There's no food anymore. Many people don't survive brutal winters. Covered with snow, Earth is freezing, and that's all because of Mars. Really? Our neighbor may play a larger role in Earth's climate than we thought before. Mars is much smaller than Earth, about half its size, and has only 1/10 of Earth's mass. Because of that, scientists used to think Mars didn't really affect Earth in any serious way. But new research shows that Mars influences how Earth moves in space, and can even impact long-term climate changes on our planet. like ice ages. A scientist named Stephen Kane wanted to test this idea. Earlier studies suggested that Mars might affect Earth's climate through gravity, even from far away. Kane wasn't convinced at first. He thought Mars was too small and too distant for that. So he decided to check it himself. To do that, he ran computer simulations of the solar system. They tracked how Earth's orbit and tilt change over long periods of time. We're talking about thousands to millions of years. These slow changes control how sunlight hits Earth, which directly affects the planet's climate. They play a key role in starting and ending ice ages, long periods of time when huge ice sheets cover parts of Earth. Our planet has gone through at least 5 big ice ages. And the current one, yes, we are living in an ice age, began about 2.6 million years ago. The first ice age started about 2 billion years ago and lasted for hundreds of millions of years. The most recent ice age is still here. Why isn't the planet frozen right now, you might ask? Because ice ages are not one long freeze. They come in waves. The cold periods are called glacials. That's when ice spreads and covers large areas. The warmer breaks in between are called interglacials. That's when some of the ice melts. Right now, Earth is in one of those warmer breaks. It started about 11,000 years ago, which is why we don't see huge ice sheets covering the planet. But let's get back to those changes that affect the planet's climate. One of such cycles lasts about 430,000 years. During this time, Earth's orbit shifts from more circular to more stretched out, and then back again. This reshapes how much energy Earth gets from the Sun. Some places get more sunlight, others get less, and this affects how ice grows or melts. Over a very long time, it changes Earth's climate. So, Kane ran simulations to see how exactly Earth's orbit changes over millions of years and found out that some of those natural cycles completely disappeared when he removed Mars. Then, Kane made Mars heavier in his simulations, and the cycle sped up because the gravity of the red planet started to pull more strongly on Earth. Apparently, even though Mars is smaller and lighter than Earth or Jupiter, its position in the solar system gives it extra influence. So, how exactly does it happen? Well, Earth's axis is tilted about 23.5 degrees, and that tilt wobbles over thousands of years. This changes how sunlight hits different parts of the planet, affecting the seasons and ice growth at the poles. When scientists created computer models and made Mars heavier, they saw that Earth's tilt wobbled more slowly. This slower wobble kept seasons steadier over long periods, which makes the climate way less extreme. This idea isn't just for Earth. In other solar systems, outer planets, even smaller ones, could also affect the climate of Earth-like planets, making their seasons more or less stable. In the future, this knowledge could help us find a habitable world. After all, Mars's effect on Earth's tilt and orbit has shaped life on our planet. Big changes in tilt and orbit caused ice ages. Forests got smaller and grasslands grew. This affected how animals evolved, like walking upright, using tools, and living in social groups. Without Mars, Earth's climate cycles might have been very different, and life, including humans, could have developed in a very different way. We could be octopus-like creatures, crawling on what used to be the ocean floor. Well, anyways, as we see, Earth's climate and life are connected to the motions of planets far away. Even planets hundreds of millions of miles from us can subtly change weather patterns here. New research shows that every 405,000 years, the gravity of Jupiter and Venus tugs on Earth in a way that slowly changes its orbit. These tiny shifts affect our climate, ice ages, and the environment where animals live. Summers get hotter, winters become colder, dry seasons get drier, and wet seasons wetter. This pattern has been happening for at least 215 million years, long before dinosaurs appeared. And it still continues today. Scientists use this cycle to tell exactly when things happened in Earth's past, like when dinosaurs lived, when mammals appeared, or when fossils formed. By studying it, they can connect changes in climate and life on Earth to small movements of other planets. Jupiter and Venus have such a big effect on Earth because of their size and location. Venus is the closest planet to Earth, about 162 million miles away at its farthest, and it's almost as heavy as Earth. Jupiter is much farther, but it's the largest planet in the solar system. Their gravity pulls on Earth, causing small wobbles in its orbit and gradual changes. During the high point of that cycle, tropical regions get more rain, so lakes fill up. During the low point, there's less rain, and lakes stay smaller. Scientists have found that this 405,000-year cycle is the most regular astronomical pattern affecting Earth's orbit and climate. And right now, we are in the middle of this cycle. The last peak happened about 200,000 years ago. These changes happen very slowly, over hundreds of thousands of years. But they still have a real effect on Earth's environment. But even with all this, human activity is affecting the climate much more. Right now, burning fossil fuels and adding carbon dioxide to the air affect Earth much more than the slow pull of other planets. Still, it's incredible to think that planets hundreds of millions of miles away can actually shape Earth's seasons and climate over hundreds of thousands of years. The sun and moon are super important for life on Earth too. Almost all animals have a built-in body clock called a circadian rhythm. This internal clock is controlled by light and helps animals and people keep track of the 24-hour day. But some animals also follow the moon. Many sea creatures depend on the tides, which the moon controls, so their feeding and reproduction happen in sync with the lunar cycle. For example, reef fish eat more food around the full moon. Even land animals follow the moon. Insects are more or less active depending on the moon's phases. Some plants, like the Ephedra feminea, also take advantage of this. It releases a sugary substance during the full moon to attract night-flying insects that help pollinate it. No wonder it's called the werewolf plant. The moon is about 239,000 miles away from Earth. Its gravity pulls on our oceans, causing tides, the regular rise and fall of sea levels. The sun also affects tides, but not as much as the moon. As Earth spins on its axis every day, tides form in two main ways. The side of the Earth facing the moon experiences a high tide because the moon's gravity pulls water toward it. On the other side of Earth, there is another high tide. It happens because Earth and the moon move around each other, which makes the water move outward. Twice a month, during the full moon or new moon, spring tides occur. The moon, Earth, and sun line up, and the sun's gravity adds to the moon's pull, making tides higher than usual. About a week later, the moon and the sun are at right angles to each other. This creates neap tides, which are lower than normal because the sun's gravity partially cancels out the moon's pull. This is a great example of how the moon, the sun, and Earth's rotation work together to create tides.
If we zoom in on Greenland from space, it looks white and calm. But deep beneath its surface, something may be moving. For years, radar scans have been showing strange plume-like distortions that couldn't be explained. Something is bending the ice from within and pushing it upward. And now, scientists finally understand what it is. Greenland is the largest island on Earth, roughly the size of the entire American Southwest. Over 80% of it sits under an ice sheet up to 10,000 feet thick. If that melts, sea levels will rise 24 feet, which in short means goodbye Florida coastlines. What's really cool is that under those 2 miles of ice lies an entirely hidden landscape. There are mountains under it, whole ridgelines sealed in. There's even a massive canyon stretching about 460 miles long. That's longer than the Grand Canyon. It was discovered only in 2013 using ice-penetrating radar. We're talking about a network of canyons untouched by sunlight for millions of years. It's the only place on Earth like this. That same radar also shows the ice's internal layers. Think of them as pages, or chapters adding to a book annually. Snow falls at around 12 degrees Fahrenheit and never really melts. It piles up, gets squeezed together, and turns into dense glacial ice. While it's stacking up, it also slowly, very slowly, drifts toward the ocean, thanks to gravity. In the deep interior, that motion is barely noticeable, maybe just a few inches per year. At least this is what scientists expect to see when scanning beneath. But in parts of northern Greenland, the story is different. Those neat layers are not lying flat. Instead, they curve upward. It looks like something deep inside the ice is slowly lifting it from below. So what's actually going on? The new idea is thermal convection inside the ice. It sounds complicated, but the principle is simple. Greenland's surface can drop below negative 40 degrees Fahrenheit, while the base, way down below, can be slightly warmer. Earth leaks heat upward, non-stop, and the pressure from nearly 2 miles of ice lowers the melting point down there. The temperature difference is small, but across that much thickness, even the smallest differences matter. The ice remains solid, yet the deeper layers become easier to deform. Over long stretches of time, that softer ice can rise in slow domes, while colder ice above settles around it, bending the once flat layers into those plume shapes radar picked up. It only happens in certain spots. The ice needs to be thick enough for that slow vertical movement to take place. If it's too thin, there's no space for the loop to form. And if it gets pulled sideways too much, the pattern gets all messed up. And that's why you only see the plumes where Greenland is both huge and pretty calm. But Greenland isn't only changing underneath, it's also experiencing transformations on the surface. Or better said, it opens from above. We're talking about real-life trapdoors in the ice called moulins. Think of them as vertical drain holes right in the middle of the ice sheet. In summer, meltwater doesn't always just trickle off the edge like a lazy river. Sometimes it finds a weak spot, tears it open, and suddenly the entire stream drops out of sight, forming a deep pit. Some moulin openings are tens of feet wide, and the shafts can plunge hundreds of feet straight down. In extreme cases, they can connect almost all the way to the base of the ice sheet. When scientists tried to make the water math add up, it just wouldn't. The only way it worked was if the moulin was way bigger inside than it looks from the top. Like the opening is just a doorway, and underneath there's a whole hidden room carved into the ice. And that detail matters, because a bigger room can store more water. More stored water means more pressure, and more pressure can make the ice slide faster. And here's the biggest part. These shafts are highways from meltwater straight to the base of the ice sheet. Water flowing down there lubricates the ice. All that water acts like grease on a baking pan. It lets the massive glaciers slide way faster into the ocean. Bigger moulins can deliver more water more often, sometimes in sudden surges. This cranks up pressure at the base and even pushes water into cracks, creating weak zones that make the plumbing network even more efficient the next summer. So there are weird plumes, there are moulins, and that's not all. Greenland has a history of straight up losing huge chunks of ice in dramatic crashes called calving. There are records of skyscraper-sized blocks of ice suddenly breaking off a glacier and vanishing into the ocean. In 2015, the Jakobshavn Glacier calved an iceberg the size of Manhattan, and in 2020, the Spalt Glacier collapsed, sending an area of ice bigger than 40 square miles into the sea. These are giant avalanches with chunks cracking, tilting, and tipping over like dominoes before splashing into the ocean. Sometimes the ice flips over entirely as it hits the water, sending a wall of icy spray hundreds of feet into the air. The sound of these crashes is absolutely deafening. It echoes across the water like an endless string of thunderclaps. When a piece of ice the size of a city block hits the ocean, it creates massive waves that can easily swamp nearby boats. Other times, massive slabs float off slowly, like frozen islands drifting away to eventually break apart into smaller pieces. We know Greenland can lose colossal amounts of ice without a giant disaster. A 1,640-foot thick section called Prudhoe Dome melted completely 7,000 years ago during a normal warming period. Greenland doesn't need to become super hot to lose ice. It just needs to stay warm for a while. Scientists also know that ice can move up from deep inside. Water can cut down through the ice, and the rocks below show that Greenland has lost big ice domes before. Perhaps the best proof, okay, maybe not the best, but certainly the cutest one, that Greenland is going through various changes is the behavior of these creatures. They might look cute to us, but they are actually very dangerous to their prey. Orcas are killer whales. They are black and white torpedo lookalikes with a dorsal fin resembling something that belongs to a Pixar movie villain. The thing is, they hunt in coordinated family groups, and they're actually smart enough to plan. They sit at the very top of the food chain. So what's going on is that orcas don't really like heavy sea ice, not because they're scared, but because it's a trap. Ice can block breathing holes or mess up their hunting, or maybe it just makes it harder to move around. So for a long time, thick ice acted like a natural fence that kept them out of certain areas near Greenland. Now that fence isn't as reliable. As the ocean around Greenland stays open for longer stretches, prey can spread into areas that used to be locked up, and orcas can follow. Animals that usually rely on the ice for a safe hiding spot suddenly find themselves completely exposed. The newly melted water basically turns into an all-you-can-eat buffet for the incoming whales. The bottom line? Orcas are reacting to the new layout. It's like watching a new boss character enter a level that used to be sealed off. The moment you see them cruising around like they own the place, you know something about the environment has already shifted. In the past few decades, Greenland has been losing ice faster than it used to, and all of that ends up in the ocean. So this isn't just a cool mystery about weird radar shapes. Sea level forecasts rely on predicting how ice behaves. If miles-deep ice acts like bubbling putty, hides massive subterranean water rooms, and shifts local wildlife, the old predictions fly out the window. Greenland is a living system holding enough water to sink Florida, making every new discovery a very big deal.